Okay, so good morning. In the last few classes, we discussed about many phase definitions we have discussed, and also we have seen some derivations also. Okay, so in this class, what we are going to do is we will take up some problems and we'll try to solve them. Okay, so before going through this lecture, you must be very thorough about all the previous lecture what I discussed, like all the phase relations, definitions, and those derivations. Okay, so all the formulas you should remember. Then only you will appreciate these problems. Otherwise, you can't appreciate. Okay. Okay. So let's start the problem number one. So what it is saying? 1 cubic meter of soil weighs 20 kilonewton. Okay, so there is 1 cubic meter of soil is there. Hmm? So suppose this is a 1 cubic meter of soil. So now what is the volume of this soil? 1 cubic meter. Okay. So 1 cubic meter is the volume, and what is the weight? Weight equal to 20 kilo Newton. Hmm? Its dry weight is 18 kilonewton. Okay, so you remember dry weight means what? Huh? There is no water at all. Okay, once there is no water, then it becomes weight of solids. Okay, so dry weight is nothing but weight of solids. Okay, how much it is? 18 kilo Newton. The specific gravity of solids is 2.67. Okay, so specific gravity is 2.67. Determine the water content. So water content they are asking, and water determine the water content. Porosity. Okay, so porosity means N. Then White's ratio, that is E, and degree of saturation, that is S. Also draw the phase diagram. Okay, so phase diagram also you have to draw it. Okay, so let's start with the water content. So what is the water content formula? Water content equal to weight of water by weight of solids. Okay, so I know the weight of water. Sorry, I know the weight of solids. Okay, how much weight of solids is 18 kilonewton, but I don't know weight of water, but I know the total weight. Okay, in the total weight, if I deduct weight of solids, obviously I will get the weight of water. Okay, so how I can get the weight of water? So weight of water equal to total weight minus weight of solids. Okay, so total weight is 20 minus 18. That means 2 kilonewton. So 2 kilonewton is the weight of water. Okay, so now put it here. So your water content equal to weight of water is 2 kilonewton. Hmm? So 2 kilonewton divided by weight of solids. So weight of solids is 18 kilonewton. Okay, so okay, so now 2 by 18 is how much? Into always water content we will express in terms of percentage. Okay, so let me multiply by 100. Okay, so your water content will be 11.1 percentage. Okay, so that you can take it as 11 percentage. Okay, so that is your water content. Okay, so first thing is done, right? Water content is over. Okay, next porosity. Okay, so porosity, how what is the formula for porosity? N equal to volume of voids divided by total volume, right? So total volume I know, because total volume they given 1 cubic meter. Okay, so 1 cubic meter I know, but I don't know volume of voids, right? Volume of voids I don't know. So how we can find out the volume of voids? And one more parameter they given, okay, specific gravity, whether I can utilize this one specific gravity. What is specific gravity? Actually, this specific gravity equal to density of solids by density of water. Okay, what is density of solids? Weight of solids divided by volume of solids into your density of water. Okay, so weight of solids I know. Okay, how much? 18 kilonewton per 18, this is 18 kilonewton. And sorry, this is not density, unit weight. Okay, so let me stick with unit weight of, sorry, unit weight of water. Okay, so same thing, density of solids is nothing but weight of solids by volume of solids. Okay, anyway, unit weight of water is there, that remains same. So weight of solids I know, that is 18 kilonewton. Okay, so volume of solids also I know, right? So what is the volume of solids? Yeah, volume of solids, that's what yeah, volume of solids I don't know, this also I don't know, but unit weight of water I know. Huh? So this unit weight of water is how much? 10, so usually 9.81 kilonewton per meter cube, but for all problems I will take equal to 10. Okay, so 10 kilonewton per meter cube. Okay, so just to simplify our calculations, that's why instead of 9.81 I am taking as a 10. Okay, okay, so volume of solids I don't know, right? So now volume of solids equal to, your specific gravity will come down. Okay, specific gravity is 2.67 into 9.81. Okay, okay, so 18 divided by 2.67 into 9.81. So this volume of solids is comes around 0.687. 0.687. Okay, so once I know the volume of solids, so this is the volume of solids. Okay, I know the total volume, then I can find out the volume of voids. Okay, so total, this is volume of solids. So now I can find out the volume of voids. So what is the volume of voids equal to? So let me get the space here a little bit. Okay, so for the space, okay, so volume of voids I want to find out the porosity, right? So volume of voids is nothing but your total volume into volume of solids. So total volume is 1 cubic meter minus your volume of solids is 0.687. Okay, so your volume of voids now becomes 0.313, 0.313 cubic meter. Okay, so now I know the volume of voids, and now and also I know the total volume. Then I can find out the porosity. Okay, so now your porosity equal to what? Volume of voids. How much I got? 0.313. 0.313 divided by total volume, that is 1 cubic meter. So for so if you want to express in decimal, it is porosity is 0.313, or if you want to express in terms of percentage, your n equal to this you multiply with 100, so then 31.3%. So this is the porosity and this is the water content. Okay, so this also I got porosity. Then voids ratio, right? So this is E, not C. So this is E. So how I can find out E? So I know the formula, right? So E is equal to N divided by 1 minus N. That I can utilize. So E equal to n divided by 1 minus n, because n already I calculated here, right? So E equal to n equal to how much? In terms of decimal, you have to place whenever you are putting in the formula, you have to put it in decimal, huh? Whenever you are expressing in terms of result, then only you put it in terms of percentage. Okay, so whenever you are putting in the formulas, then always you have to express put it in terms of decimal. Okay, so you 0.313 divided by 1 minus 0.313. So E equal to 0.456. So this is the White's ratio. Okay, so White's ratio also I got. Now degree of saturation. Okay, so how I can find out the degree of saturation? So S equal to what? What is the formula for degree of saturation? So volume of water by volume of water divided by volume of whites, or I can use one more formula. What is that? SE equal to W into GS, because already I found out the W, I found out GS I know, and also I know the E. Okay, so this formula will be convenient to use. Okay, so now S equal to, what is the water content? Water content is 11.1%. That means in the formula you have to put it in terms of decimal, 0.11 into specific gravity. Specific gravity is given 2.67. 2.67 divided by E. E is how much? 0.456. 0.456. So your degree of saturation is 65. Sorry, first let me express in terms of decimal, then put it in terms of percentage. 0.65. Okay, that means 65 percentage is your degree of saturation. Okay, so water content, how much we got? 11%. Porosity, how much we got? 31.3%. White's ratio 45.6%, and degree of saturation 65%. So very simple problem. First problem, it's very simple. Okay, so here also answers are given, so just you can tally them. Now come to the second problem. Okay, so let me delete this. Okay, so second problem, just you read it here. What are they given? So they given White's ratio, they given, right? So let me write what are the given parameters. Given White's ratio, that is E equal to 0.62, and water content they given, water content equal to 15%. Okay, then density of solids. Okay, so density of solids, that is rho S equal to 2.65 megagram per meter cube. Okay, so density, now you convert it into unit weight of solids. Okay, so this unit weight of solids equal to this megagram is 2.65 into 10 to the power of 6 gram per meter cube. Okay, so for this, if I multiply with 10, then it will become kilonewton per meter cube. Okay, so 2.65 into 10 is 26.5. 26.5 into 10 to the power of 6 is nothing but kilo. Okay, so kilo Newton per meter cube. Okay, so yeah, density of solids they given. Then what else? So density of solids they given. Now that density of solids I convert into unit weight of solids. How I converted? 2.65 megagram. Megagram is nothing but 10 to the power of 6, right? And gram per meter cube. Okay. So this gram is there now. To convert this gram into Newton, then I have to multiply with the 9.81. Okay. So instead of 9.81, what I'm assuming it as a 10. Okay. That's why it becomes 26.5 kilonewton per meter cube. So density of solids they given. Okay. So what are the things they are asking? They are asking dry density. Okay. So dry density. Okay. And degree of saturation they are asking. What is dry density and what is degree of saturation? Then water content they are asking. Water content for 100% saturation. Okay. So this is for S equal to 100%. Okay. Then and saturated density. Okay. Saturated density also they are asking. Okay. Okay, first let me start with the dry density. Okay, so what is the formula for dry density? Dry density is equal to gs into gamma w divided by 1 plus e. Okay, so specific gravity, whether they given any specific gravity. So specific gravity they are not given, right? Okay, I can find out the specific gravity. So what is after all specific gravity? Gs equal to density of solids divided by density of water. Okay, so density of solids, how much they given? Density of solids, don't put it in terms of unit weight. Okay, so because they are asking in terms of densities only. Okay, they are not asking in terms of unit weight. Okay, they are not asking dry unit weight. Okay, so if they are asking dry unit weight, then you can proceed with the unit weight of solids. Okay, because since they are asking dry in terms of density, then I will continue with the densities only. Okay, so what is the density of solids? That is 2.65 megagram per meter cube. Megagram per meter cube. Okay, divided by, so unit weight of water. Okay, so unit weight of water is nothing but 1 gram per cc or 1 megagram per meter cube. Okay, since numerator is in terms of megagram per meter cube, let me put in terms of megagram per meter cube. Okay, so if it is in gram per cc, then you should continue with the gram per cc. Okay, so this is 1 megagram per meter cube. Okay, so megagram per meter cube, megagram per meter cube. So hence specific gravity is unitless. Okay, so there is no unit for the specific gravity because numerator and denominator is having same unit. So specific gravity becomes 2.65. Okay, once I know the specific gravity, and this, instead of unit weight of water, I will put it in terms of density of water, because everywhere they are asking densities, not unit weights. Okay, so now dry density is equal to, your specific gravity is 2.65, and your dry density of water is 1 gram per cc or 1 megagram per meter cube, divided by 1 plus e. E is how much? 0.62. 0.62. Okay, so now your dry density is equal to, so this in terms of megagram per meter cube. So then, so whatever density you will get now, that is in terms of megagram per meter cube. Okay, so how much you are getting? So once you calculate this, it will turn, it comes out around 1.635 megagram per meter cube. Okay, so that is the dry density of soil. Okay, so where is the 1.36 dry density of soil I got? Okay, Next is the degree of saturation they are asking. Okay, so degree of saturation is how much? Okay, they are asking degree of saturation. Okay, so how I can find out? Either degree of saturation means I have two formula, right? So this is second point. Okay, not, I will put it as B. Okay, so degree of saturation can be volume of water out of volume of voids, or I can use this formula also, SE equal to W into GS. Okay, so this is more convenient because all the parameters we know except degree of saturation. So S equal to, what is the water content? 15%. Okay, so 0.15 into specific gravity. Specific gravity is 2.65. 2.65 divided by your White's ratio. White's ratio is 0.62. So 0.62. So hence your degree of saturation is 0.641. Sorry, 0.641 or 64.1 percentage. Okay, so see whether how much I am getting. Yeah, see, this also over. Okay, now comes the bulk unit weight. How I can find out the bulk unit weight? So what is the formula for the bulk unit weight? Remember? So let me get some space here so that I can continue here. Okay. So my third term is find out the bulk density. So formula for the bulk density is GS plus SE into density of water divided by 1 plus E. Okay, specific gravity is how much? 2.65. So 2.65 plus your degree of saturation. Yes, just now we found out. Okay, so how much? 0.641. So 0.641 into White's ratio. White's ratio, how much they given? E equal to, so E is equal to 0.62 they given, right? So E equal to 0.62. Yes, 0.62 into density of water is what? 1 megagram per meter cube. So whole divided by 1 plus E. E is how much? 0.62. So you will get, once you simplify, you will get around 1.881. 1.881 megagram per meter cube. Okay. So let me check. Yeah, 1.81 megagram per meter cube. So next is the water content. Water content for the once it become 100% such, see this 60 degree of saturation at 64.1, what was the water content? So around 15%. Okay, now if I saturate the soil, fully saturated, okay, around 100% saturation, then at that point, what is the water content they are asking? Okay, so that thing we will see here. So get to some more space here. So CD. So D is what? What is the water content? So what is the water content at degree of saturation is 100%. Okay, so don't confuse with water content. Okay, so here already some water content they given. Okay, this water content is for the 64.1% saturation. Okay, so once the saturation increases, obviously the water content also will increase. Okay, so don't get confused whether they, because already they given water content, then why you are asking, why you are calculating again water content. Okay, so this water content is for the 100% saturation. This water content is for the 100% saturation. Okay, so whatever this water content is there, now this water content is for the 64.1% saturation. Okay, so what is the formula we have? Yes, E equal to W into GS. Okay, so yes, E is what? S is 1. S is 1 into E. So what is E? White's ratio. So White's ratio they already given 0. 0. Given White's ratio 0.62. Okay, so 0.62 divided by specific gravity. Specific gravity also they given 2.65 is water content. So calculate how much you will get. So you should get water content of 23.4%. Okay, so this is the water content at S equal to 100%. Hmm? So this is 23.4. Okay, and also they are asking saturated density. Okay, so they are asking saturated density also. So let me write that formula also. E equal to rho S equal to Gs plus E into density of water divided by 1 plus E. So Gs is how much? 2.65. 2.65 plus E equal to 0.62 divided by 0.62 plus 1. Okay, so into density of water. Density of water again 1 megagram per meter cube. Okay, calculate gamma sat. You should get something around 2.019 megagram per meter cube. 2.019 megagram per meter cube. Okay, so this is the saturated density. Okay, so all the parameters we have calculated. Okay, 2.01 megagram per meter cube. Okay, so two problems we have seen. Okay, let me go to the third problem. Okay, so this is the third problem. Okay, so let me go through this problem. What they given? A silty clay with a specific gravity 2.7. Okay, so what is the specific gravity they given? 2.7. Okay, and degree of saturation 100%. Water content 46%. Determine E. What they are asking? E they are asking. Saturated unit weight, gamma sat they are asking, and buoyant. Okay, so buoyant or submerged unit weight, both are same. Okay, submerged unit weight is gamma dash they are asking. Okay, so first I have to find out the E value. Okay, so recall that equation, that is SC equal to W into GS. Okay, so E equal to W, water content is 46%, that is 0.46 into specific gravity 2.7 divided by degree of saturation, that is 100%. Okay, so that means 1. So E equal to 1.242. Okay, so E value will be this much. Then what they ask, they are also asking gamma sat. Okay, that is unit saturated unit weight. Gamma sat saturated unit weight equal to Gs plus E into unit weight of water divided by 1 plus E. So what is Gs? 2.7 plus E. E just now we found out 1.242. 1.242. Okay, so unit weight of water is usually actually it is 9.81 kilonewton per meter cube. Sorry. Okay, so unit weight of water equal to 9.81 kilonewton per meter cube. Okay, so in the previous problems, instead of unit weight I written density of water. Okay, so please remember, please see the difference between density of water and unit weight of water. Okay, so density of water is 1 megagram per meter cube, or this is nothing but 1 ton per meter cube, or 1 gram per cc. Okay, sorry, let me write this thing properly here. So delete this. Okay, delete this. Okay, okay, so what I was telling is, see here, I am using unit weight of water, that's why its unit weight of water is 9.81 kilonewton per meter cube. But in previous example, we have talked about density of water. Okay, so in that case, how density of water, how much we took, we took 1 mega gram per meter cube we took. Okay, which is equivalent to 1 ton per meter cube. Okay, which is equal to 1 gram per centimeter cube. Okay, so but here we are using unit weights. Okay, whenever I am using unit weight, the unit will be kilonewton per meter cube. Okay, whenever I am using a density, the unit will be ton per meter cube, gram per cm cube, or megagram per meter cube. Okay, so please have a observe this difference. Hmm? So this will be 9.81 divided by 1 plus E 1.242. 1.242. So now gamma sat. So your gamma sat should come around 17.23 kilo Newton per meter cube. Okay, so always you should be very careful about these units. Okay, so density is in the previous class. See this density, saturated density, I expressed it in terms of megagram per meter cube. Okay, but in this example I am expressing the density or in terms of unit weight. Okay, unit saturated unit weight, that is gamma. Okay, have a look at this difference. This is rho saturated, this is gamma saturated. Okay, so rho saturated units are in terms of gram per cc, or megagram per meter cube, or ton per meter cube. The unit of units weights are in terms of kilonewton per meter cube. Okay, okay, next one more quantity they ask, that is submerged. Okay, submerged density, submerged unit weight, or buoyant unit weight, both are same, gamma dash. So gamma dash is equal to gamma sat minus gamma w. So gamma sat is 17.23 minus gamma w is how much? 9.81. Okay, so instead of 9.81, sometimes I will take 10 here, and don't get confused. So sometimes this is equivalent to 10 kilo Newton per meter cube. So here I can take, you take either 9.81 or 10. Okay, both are okay. So if I take 9.81, I will get 7.43 kilo Newton per meter cube. Okay, so instead of 9.81, if I take 10, then I will get 7.23. There is no much difference between if I take 9.81 or 10. So this is by gamma dash. Okay, so gamma dash is 7.43. Sorry, 7.4 kilonewton per cubic meter. Okay, so coming to the last problem, fourth problem. Okay, so what it is telling, fourth problem, you see, Mm, so an oven dry sample of volume 250 cm cube. Okay, so there is a one soil sample is there. Okay, what is the volume of this one? This is the oven dry sample. Huh? Oven dry. Oven dry means what? Whatever weight is there. No, this entirely weight is the weight of solids. Okay. So what is the volume? Total volume they given 250 cm cube. 250 cm cube, centimeter cube. Weighs 430 grams. Okay, so total weight they are giving. Okay, so that is the total weight 430 gram. Okay, so this total weight is nothing but weight of solids only, because it's a one dry sample. One dry sample means there will not be any water at all. The specific gravity they given 2.7. Okay, so gs equal to 2.7. Okay, so what is the water content when soil becomes fully saturated without any change in its volume? Okay, so what they are asking? They are asking the water content at S equal to 100%. That is degree of saturation. They are asking this one. So how we can proceed? Yeah. So first, let me find out. See how I can find out the water content. Water content will be weight of water divided by weight of solids. Okay, so I know the weight of solids because 430 grams they given. Weight of solids is 430 gram, but I don't know the weight of water. I don't know weight of water. So okay, I know the specific gravity. Whether I can uh, let me start with the specific gravity. Okay, so what is specific gravity? Specific gravity is nothing but density of solids by, sorry, unit weight of solid by unit weight of water, that equal to or density of solids by density of water. Huh? So let me check densities. They're not given. Okay, yeah. So density of solid is nothing but density of water will be 1 gram per cc. Okay, so this density of water is 1 gram per cc. So density of solids they given. What is the density of solids? Density of solids, I can write it in terms of mass of solids. Mass of solids divided by volume of solids. Okay. Um, so actually it's not weight. Okay, so see the unit. Okay, so they given in terms of gram, right? If they given in terms of gram, then it should be the mass, not weight. Okay, so this is mass, and also this is mass of solids. Okay, you see the unit here. Unit is in terms of grams they given. Okay, so once they are given in terms of grams means that must be the mass. Okay, yeah, for the weight they will give in terms of kilonewton or newton. Hmm? If they are giving the weight, then in terms of kilonewton or newton we will give. Okay, so this word is the no this word is very confusing. Okay, so ways they are telling, no, so this should be ways means the uh, common thing will come to in our mind is like W. Okay, so but you should see the unit here, what unit they are using. Okay, so they are using a gram unit. Okay, that means it's a mass unit, not a weight unit. Okay, so mass units they are giving. Okay, let me come here. Specific gravity equal to mass of solids by volume of solids. Okay, so mass of solids is how much? 430 gram. Hmm? So specific gravity also they are given. Okay, so let me calculate volume of solids here. Okay, so total volume they given. Okay, so this total volume is 250. Okay, so in this total volume, some volume is occupied by air. Okay, since it is a one dry sample, there is no water at all, so all the volume of whites is occupied by air. So now I can find out the volume of solids here. So volume of solids equal to mass of solids divided by your specific gravity. So mass of solids, how much they given? 430 gram per 430 gram. Okay, divided by specific gravity, how much they given? 2.7. 2.7. So now you see 430 by 2.7, it will be around 159.26 centimeter cube. Okay, volume of solids I got. Now I know the total volume, I know. Okay, so I can find out the volume of whites. So my volume of whites equal to total volume minus volume of solids. So what is the total volume? 250 cm cube. 250 cm cube minus 159.26 cm cube. So this volume of whites equal to you will get around 90.74 cm cube. Okay, yeah, volume of whites. Now I know the volume of whites. Okay, so what is the whites ratio? E is equal to volume of whites by volume of solids. So volume of whites is 90.74 cm cube, and volume of solids, this is the, yeah, here volume of solids is here 159.26 cm cube. Okay, so your how much you will get? 90, let me calculate here. So 90.74 divided by 159.26, so 0.569. Okay, so I 0.569. Okay, that can be taken as 0.57 is the whites ratio. Okay, once you know the whites ratio, okay, so I can calculate, I know the formula. Yes, E equal to what? W into GS. Okay, so what is our motto? Our motto is to find out the water content, right? So water content equal to SE by GS. So S is anyway for the 100% saturation. That means 1 into E. E just now you found out 0.57 divided by specific gravity. Specific gravity they given, right? So specific gravity, how much they given? 2.7. So your water content will be 0.211. That means 21.1 percentage. Okay, so this is the water content. So answer is water content at S equal to 100% is 21.1 percentage. Okay, so there is a second part here. So what is the second part of the problem? So second part is what will be the water content which will fully saturate the sample, okay, and also cause the increase in volume by 10%. Okay, so what will happen? The total volume is now increased by 10% due to excess amount of water. We are, see, at 100% saturation, again, again we are adding some more water. Okay, so how much, what is the water content which will increase your volume by 10%? That's what we want to find out. So they are asking the water content. So this second part, okay, second part is what is the water content, okay, at uh, at more than s at more than at s equal to more than 100%. Okay, that means your total volume is there now. Total volume is increased by 10%. Sorry, let me write here. Increased by 10%. Okay, so total volume now it is has been increased by 10%. So at that volume, what is the water content they are asking? Okay, so that we have to find out. Okay, come to here. So second part of the problem. Second part of the problem. Problem number 4. So they are asking water content at volume, total volume, so total volume increased by 10%. Okay, now your total volume, earlier how much it was volume? Earlier was 250 cm cube. Okay, now it is increased by 10%. Okay, that means 250 plus 250 into 0.1. 10% means 0.1. So this will be your you will get 275 cm cube. Okay, so your total volume is no more to 250. Okay, now it has been become 275 centimeter because of excess of water. So like this it is. Suppose this is your three-phase diagram is there. This is the solids. Earlier was this much was the water. Okay, this is the solid, this much was the water, and this was the total volume. Okay, this one was the total volume. Now what I happened, I added some more water here. Okay, I added some more water so that your total volume now becomes more than, sorry, what happened? Yeah, this now your total volume is nothing but this is the new volume. Okay, so new volume is 1.1 times your old volume. Okay, so how 1.1 times your old volume VO. So this is the older volume VO. So let me write it a little bit bigger here. Suppose this is the earlier older volume VO. This is the newer volume VN. How much it become? 1.1 times volume of watts. Okay, so now your total VN, that is new volume. New volume I will write. Instead of new volume, simply I will put it as a volume on it. Okay, so just for the demonstration purpose, I put it N here. Okay, so obviously this is a total volume. Now total volume, how much it is? 275 cm cube. Okay, so your total volume is increased, but your volume of solids remains same. Okay, volume of solids remains same because your volume of solids, by adding water, nothing is going to change your volume of solids. Okay, so volume of solids remains same it is. Okay, so how much it was earlier? Earlier we have calculated it as 159 point, sorry, 159.26, sorry, 159.26 centimeter cube we have calculated this earlier. Okay, this is not going to change volume of solids, only total volume has changed and volume of voids also will change. Okay, so obviously volume of voids also will change because this has to be remain same and this is increased by 10%. So volume of voids is nothing but total volume minus volume of solids. Total volume is 275 cm cube minus volume of solids is 159.26 cm cube, right? So your volume of voids become 115.74 centimeter cube. Okay, so this is your volume of uh, voids. Okay, now what is the new voids ratio? Because voids ratio is now new void ratio is equal to, because what is after all voids ratio? Voids ratio is volume of voids by volume of solids. Okay, so volume of voids is 115.74 divided by volume of solids is same only. Volume of solids is remains same, 159.26 cm cube. 159.26 cm cube. Okay, so this is also in terms of cm cube, this is also in terms of cm cube. Now how much it will come? So 115.74 divided by 159.26, so it comes around 0.726. Okay, so your new E is equal to 0.726. So now I want water content, right? At yeah, this is my motto to find out. Okay, so coming to the same formula, S E equal to W into GS. Okay, so I want W. Okay, so W is equal to, anyway S will be 1 only. It is still, it is 100% only. Okay, so E is 0.26. Sorry, let me write the formula. Then I will substitute W equal to S E by GS. So S is equal to 100. So E equal to 0.26. Sorry, 0.726 divided by specific gravity is 2.76. How much specific gravity is? Specific gravity also same only. It is not going to change. 2.7. So calculate water content will be 0.269. Okay, that means 26.9 percentage. So this is the water content. Okay, so these are the problems today we have solved. Okay, so what I suggest you go through this video carefully. Okay, so carefully you go through once again all this video. Then if at all any doubts are there, then you can ask me in the live sessions. Okay, so let me stop the lecture here. So stop.